Chapter 5, Probability. What are the chances is the title of this. Well, when we think about probability, we probably think about flipping a coin, rolling a die, and that is probability. And you guys already have a very good idea of basic probability. If you flip a coin, what's the probability of heads? All of you will say 1/2. If I roll a dice, what's the probability I roll a number 3? Oh, 1 out of 6. There's 6 numbers on a die, and one of them is a 3. So the basic concept of probability, everybody understands. You guys already have that idea. What are the chances that this happens? We can talk about probability as a fraction, as a decimal or proportion, or as a percentage. All three of them would work just fine. Oftentimes, we'll use the percentage one more frequently than the other two, but any of the three answers would be fine. Either a proportion, decimal, or a fraction, or a percent to describe the probability. So what's the probability I flip heads? Oh, it's 1/2. Oh, it's 50%. Oh, it's 0.5. All of those are suitable answers for a probability question. Well, what technically is probability? Okay. Probability of any outcome occurring is the proportion of times that it would occur in a very, very long series of repetitions. So probability answers what would happen if I were to do this over and over and over and over and over again. Every single probability answer must be a number between 0 and 1. So for example, what is the probability that event A occurs? It has to be some number greater than or equal to 0 or less than or equal to 1. What does it mean, the probability? If the probability is equal to 0, what does that mean? That means that there is absolutely no chance of that event occurring. The probability of an event equals 1, that means guaranteed, for sure, certainly, this is going to happen. Any value in between. So the probability must be a number between 0 and 1. Or if you like percentages, between 0% to 100%. So the probability is any number between 0 and 1. Probability follows the law of large numbers. Over the long run, probability answers what's going to happen. If I flip a coin twice and the probability of heads is 0.5, does that mean that every 2 times I flip it, I'm going to get exactly 1 head? No, because that's not a long run. That's not many, 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 many trials. Probability is answering what would happen over the long run, or as you can see here, the law of large numbers. The law of large numbers says that as we observe more and more repetitions, the proportion becomes closer and closer to the true probability. Or you could think about this as the sample mean X bar starts to approach the true population mean mu. We have a couple of examples here, or graphs. An activity that we'll do in class is we'll flip a coin 10 times and record the number of heads. Well, on the first flip, there's no way that it can be 50%. It's either going to be 0 or 100. So as we start to flip the coin more, if we flip the coin twice and we had 1 heads and 1 tails, well, then we'd be at 50%. But on the third flip, there's no way to get back to 50%. But as you can see here, as the number of flips starts to increase, the proportion of heads starts to get closer and closer to what we know the true answer is going to be of 0.5. And that's what the law of large numbers says. That's how casinos thrive. Because over the long run, they know exactly what's going to happen and what percent of all bets they will win. But probability is cool in the sense that, why is it fun? Why do we like to gamble? What's cool about it is we don't know what's going to happen on any singular trial. On one trial, are you going to get heads or tails? I don't know. The probability I get heads is 50%, but I don't know what's going to happen. If I flip the coin 10 times, does that mean I'm going to get exactly 5 heads and exactly 5 tails? Absolutely not. As you can see in our example here, after 10 flips, we only had 30% heads. But as the number of flips increases and we start to get more and more, the second graph here is showing us somebody who flipped a coin 500 times. And you can see at the beginning, the variability was quite high. We were all over the place. But as the number of flips increases, the proportion of heads starts to get closer and closer and closer to the true population's proportion of 0.5. So the law of large numbers says over the long run, I can tell you what's going to happen. What's the long run? I don't know, but many, many, many trials. There's not a fixed number of trials for it to be the long run. Because the law of large numbers says probability can answer what's going to happen over a large number of trials, but we cannot tell you what's going to happen on any individual event or trial. So that's what makes gambling and probability so interesting. Is over the long run, I know what's going to happen, but over the short term, I do not know what's going to happen. There is a fallacy. It's fake. It's not true. But a lot of people believe in the law of small numbers. For example, if I flipped a coin and I got 10 tails in a row, a lot of people would say, oh, the next number has to be heads because the probability is 0.5. It's got to start evening out. Well, we don't know what's going to happen on any individual event. That would be the example of the law of small numbers, which is fake. There is no law of small numbers, even though a lot of people believe in it. Oh, I got 10 tails in a row. Well, I'm due for heads. It's heads got to start coming up here soon. No, each trial is independent. The coin doesn't know that it just flipped 10 tails in a row and now it has to flip heads. But over the long run, that proportion will even out and get us to that true probability of 0.5. So that's what the law of large numbers here is stating.